rectangular. Yeah.
Obvious.
YouTube using the cloth simulation now. You can like puff it up like a pillow.
To the magician at work, boys. A magician at work. Look at him working his magic here.
No. I used to be a 3D artist. I'm not anymore.
So is a Fresnel lens essentially just a parabolic curve that's flattened into a flat rectangle?
It's flattened into sections. They take circles that are centered on each other. They cut out circular sections, and then they make a prism that equals that angle that the lens is to 0.
So if you expanded all those sections out, would it be a parabola?
Right. If you lined up all those at all the surfaces, it would be the curvature of a lens. If you moved all the different circles in a line with each other so that the angled faces match, lined up with each other. Curves.
Are all lenses parabolic?
No, some lenses are spherical.
They sometimes use this magnification to say that's why that the bottom of items are obscured. So if you had like a mini tower rather than a ball, and put that at the far back, and then put the big rectangle of glass at the far back, and then looked at it from a distance, you should cut out when it magnifies, and that's what they claim that things disappear from bottom up. It's just the atmosphere acts as a lens, increasing the size of the item, which is then obscures the bottom of the item. So you could use this demonstration to quite reenact this phenomena that they're claiming. The atmosphere.
Now, does that effect require any particular type of magnification or an angle, or is pretty much any magnification going to?
It has to be like kind of a wild, like the square one. It's got a big wild field of view, and say it's got a tower in the background. It's blowing up the tower in the background, and because it's blowing up the image, the bottom of it's going underneath the horizon. And because of the image in the background being magnified, that's why I'm saying if he puts one of the balls at the end, or like a fake tower, and then puts the magnifying there, it should make the image bigger, and then it would cut out the bottom, and that's why they're saying it's not curvature hiding items. They're saying it's magnification blowing up the image, which is hiding the bottom. Did I explain that clearly?
Yeah, I'm just curious if the exact shape of the lens matters, or if that same effect would be achieved with any type of.
I think when it's got a spot lens, it's only like looking through like a telescope, isn't it? Like you're looking through like a binocular. But you know, to kind of reenact the effect, I think it would be a bit less harder to criticize if they had a large white field of view. Hence why I asked them to use the lens on the left with the big square block, just because it kind of. I think the obvious debunking of it, or the obvious rejecting of the evidence of that would be, that's not the lens we see through life, because the whole field of view is the lens. They're claiming the whole field of view, so you'd have to reenact it as close as you can to reality.
Enlarge the lens. You'd have to scale that lens up big for it to work. Like.
Well, the atmosphere is obviously not shaped like a lens.
No.
So, what are they claiming that
moisture gathering at one place or in an area enough to magnify like that, it would be fog.
Yeah. I mean, are they claiming that it's some sort of temperature gradient that causes this, or I don't know what would cause
spherical temperature gradients?
It's a rationalization to not believe in the globe. That's all it is. It's just a distraction and a rationalization. Well, it could happen like this, so I can't.
Oh no, they don't. That's the best part, because all they have to do is say that there could be an option, and because they came up with it, it must have equal value to our description. Therefore, they're just as correct as we are.
You said it far better than I could have. Thank you.
Everything about flat earthers.
Yeah. Any kind of thing they come up with, we have to take seriously because they thought of it.
Yeah, no, right hand turned around earlier. You said, when I pick up any rock on the Earth and drop it, it falls to the ground. So when I look at the moon, it doesn't fall to the ground. I know it's not the same. It's obviously, it's obviously not a rock. The moon is not a rock because when I drop rocks on Earth. And then I goes to him, well, I said it's in a different medium. It's in space. He goes, oh, you've never been there to confirm it. So how can you tell me that? I goes, well, how can you tell me how that rock in the sky is supposed to behave when you haven't been there yourself? And he starts, you know what I mean? Like
that is some god tier level logic that he's got right there.
The rock on Earth is in the same medium that the moon is in. They're both in the same medium.
That's not true.
You can't confirm because you've never been to the moon. You've never been to the moon. You can't confirm it.
And your model, we're going off your model, and your model, it's in the same medium.
You can't go to the moon and confirm it's the same medium or not. So that's.
Wait.
His error is though that he's taking one property of the behavior of rocks on and using that as the complete. So like this rock drops, therefore all rocks drop, and anything that doesn't drop is not a rock. That's just, that's just one thing you know about the behavior of some rock. You know,
all rocks do drop. It's just that the moon is traveling extremely fast in a going sideways.
Essentially, it's a giant love child of a hasty generalization fallacy strapped to a multiplication fallacy.
Right.
So if you take any rock and you make it go sideways at however many miles per hour, then yeah, it's going to do the same thing that the moon's doing.
What the hell have you done to reality, Stingray? What the hell have you done?
I'm trying to create diffractive collinear atmospheric magnification. I'm epically failing, which I seriously doesn't surprise me at the moment. So.
Well, I can show you a video where that effect is happening.
Jeremy, you say that the moon is in the same medium as a rock on Earth?
Yeah, said it, Brimmy.
Yeah, sorry, Jeremy said it, but Jeremy was backing up right the hands
right.
argument.
Now I'm trying to find out what he means by that.
Yeah, well, the moon is in space, and the rock is in, and it's just empty space.
Right, but that's the same medium as on the ground.
All right, what mediums do you think the rocks are in?
Anything.
Hey,
okay,
are you guys ready? I'm about to
make
the globe out of the water. You guys ready for this?
We can make.
If the moon was in air at 14 psi gradient, like at the surface of the Earth, it would gain mass and fall to Earth.
That's why it's logical to assume, that it's obviously under some, it's in space and it's under some sort of other gravitational pull, and there's something else affecting on it because, it defies our understanding of rocks on Earth. And not every rock sinks to the bottom of the water that someone else pointed out. Some rocks float on water, so not all rocks behave the same on Earth either.
Yeah, that was a point Druss was actually trying to bring up earlier. If you'd only ever been exposed to pumice rock, you would assume that all rocks float.
We're not talking about the medium of water, though. We're talking about the medium of space.
No. It's not a matter of the medium. It's a fair of exposure by saying that he's never experienced it XYZ under XYZ under ABC constraints to dismiss information. If I've only ever been if I'm just a person who's only ever been exposed to pumice rock, I can assume that then by his logic, all rock must float.
Yeah.
We're not all rocks.
Still,
do
though,
float, we know
when-
that.
we're not
Jeremy,
talking
it's
about
really not about a different medium. It's a point of logic. It's about the fact that he's taking this single property and using it and saying all of the rocks must be have this single property or they aren't rock.
Which property?
They fall to the ground.
They fall.
Yeah. The moon falls to the ground too. It just also goes
It
sideways.
doesn't fall to the ground. Dude.
No. I mean, I'm saying like it's falling. It's just going sideways.
Right,
fast.
but it doesn't fall to the ground in the way that he sees it.
It's in the process of falling to the.
I think the
Right,
hand
Jim-
point was you can't.
Is it the moon going further away from us, though?
I'm sorry, Jeremy. I stepped on you. Go ahead.
I think the hand's point was you can't demonstrate it falling sideways or floating or whatever you want to call it.
Jim Panda already said to him, look in the sky, you've got your demonstration right there.
Yeah, throw a rock and watch how it goes sidays and then falls. Right. That same principle. That same principle applies if you go extremely fast to the left.
I bet if with a railgun you could demonstrate the effects of gravity just by the speed of that. It probably hits the ground a little bit slower than if it was dropped.
Like people, right? They're not just going straight down. They like you can fall and not reach the ground. You know what I mean?
If you using a ballistic trajectory, using the ballistic trajectory for a rail gun on a flat Earth versus a round Earth, you can pretty accurately predict when the projectile will touch the ground in terms of time, as long as you know the speed of the projectile, and a few other small details.
Frost, are you confusing that the International Space Station is slightly falling towards Earth, right, mixing it up with the moon? Because I don't think the moon is falling towards the Earth. I think
It is falling, but it's not.
Yep.
It's not falling in the visual way that he can pick up a rock and see it fall on Earth.
Is he not
It's
getting
just
further
the
away
ratio.
from us, though? Isn't the moon going further away from us? It wouldn't be coming closer, though, would it? It's going further, isn't it? Like an inch every 10 years.
That's
Somebody-
right. It is pulling away from us, yes, slightly.
So
I just say it's falling. It's falling incorrectly then, or it's falling wrongly if it's moving.
What I'm trying to say is that if you take the math for ballistics, right? The ballistic math will in fact create an orbit as well if you just scale up the numbers.
Sure, but he isn't. He's a planet behave. It's not how he sees a rock behave on it.
Yeah, but he's a moron.
I know. But, at the end of the day, it's hard. Okay for him to just assume, dropping a rock, therefore, it's not a rock because rocks drop. And then when I say how the moon works, you went double standards.
Well, he knows it's just a light in the sky.
And he
Lights that we've
Exactly.
it's like,
never seen a
and
light
but,
bulb with a
but
shadow
he-
casted on it.
yeah,
An illuminated
but the
light
thing
bulb
is-
with a shadow.
yeah, not only that, but he reject any way of differentiating it from any other light.
What do you mean?
So you say that he says, "Oh, it's just a light." It's like, no, it's physical. I can bounce radio off of it. He'll say, "You could do that on the sky next to it." It's like, "Well, go try." And he'll say, "No, I don't have to."
It's ridiculous. I never really thought of that, though. It's a physical object that you can reflect from, isn't it? You can do that to the sun, I'd assume, as well. Isn't that how they determine the distance route as well, like, say, radio waves?
It's a little bit more difficult to do with the sun, but there are papers of how it's been done. You need a different array set to radio range the sun. You can radar range the Venus, though.
So you can make sure that the sun is at least further away than Venus.
But I mean, isn't a good argument, and I might be wrong, but isn't a good argument fire, a bulb, spark, heat on metal? These are all things that generate light. They are all physical that generate light. Can you please point to the one thing that isn't physical that can also generate that amount of light?
Actually, he would have an argument for that because he thinks that the definition of photon doesn't meet the threshold for physicality.
I was purely arguing from an inference, as in my reality, I can connect four things to an effect that are physical. I've never been able to have one of those things be non-physical and see that.
Yeah,
so
I get it,
therefore,
yeah.
it's just made up.
It's like saying you in like how he drops the brick. You could say, well, what light source do you know that doesn't come from a physical source? You'd need a physical source for what do you have in your reality? Like you drop the brick and you assume that it can't be a brick. So what sort of light do you have that's a non-physical thing that generates light and heat? Because that's what we get from the sun, heat and light, right? So there's no way on Earth we could have anything that would generate heat and light with it being coming from a physical thing.
Is energy, light, and stuff not physical? Because I mean, by my definition, it is physical. My definition is that it can cause physical effects.
I wouldn't say light was
Therefore, it is
physical, but I'd say energy was, yeah.
It's tangible.
And light can travel at like light speed, so it can't. A physical thing can't travel at that fast. But
Right,
energy.
but Jeremy, that's your definition of physical. Just wondering if the definition of physical can include light and energy.
Things physical. The question is
physical.
Is it really?
If it's physical, in my definition, it's physical.
No, we're saying relates to physics.
Yeah. If anything's tangible, physics is going to consider.
Electricity travels at the speed of light as well, doesn't it?
Well, pretty much, depending on the medium, though.
Well,
I haven't done a test for wires for passing electrons. I'm guessing there'll be a slowdown depending.
It's about 75% of the speed of light.
Okay, so it's because so there's obviously physicality to that electric.
It's completely physical. It's pushing one electron to the other electron. It's the charge pushing across the actual of the wire.
Physical, but light. Light photons.
Yeah. 86%.
Light.
It's tangible.
Well, pretty much everything